Here is the finished myDewController project. 2 G-straps with RCA, fan here, 2 temperature probes which are wired with a 6P4C connector, 12 volts power, Bluetooth adapter down the bottom there. Here's USB. This is a DHT22 relative humidity temperature sensor. A 2004 LED display, LEDs for each of the G-straps, LED to indicate the speed of the motor, fused of course, 12 volts power on off, and these are override switches which give 100%. So this can be operated as in standalone mode, so connecting up the 12 volt supply like that and turning it on, you can see it's detected 2 probes, 2 temperature probes. It's giving the ambient temperature, the humidity. The display is in Celsius mode. The dew point, the tracking mode of this device. It has 3 different tracking modes: ambient, dew point, or midway between the 2. The fan speed is off. The channel 1 temperature is 23.2 and the channel 2 temperature is 23.0, and the power applied to channel 1 and channel 2 is currently 0%. I can override this just by flicking the switch on. You see the LED comes on and power now is 100% to that particular G-strap, so I'll just turn it off. These are DS18B20 probes. So I'm currently using probe 2, so we would expect this temperature here to go up very shortly. There we go, it's starting to respond immediately. It's now up to 25 and so on. So that's it operating in standalone mode. What I'll do now is show you it operating with a Windows application. I've got the USB port connected. I'll just turn on the 12 volt power as well. It doesn't matter which way you connect, 12 volts first or USB first, doesn't matter. And this is the application program, myDewControllerPro. It's on COM4, so we'll connect up to this device. It's telling us please wait while it gets all the information. And you can see here that once we're connected, we'll do a manual update. And relative humidity 55, ambient temperature 21.4. so all the parameters are here. This is the tracking mode, so at the moment it's tracking dew point, so it'll keep the G-strap temperatures just above dew point. The fan speed is 75. I can directly change it to make it go 100. The AT bias offset is for adjusting the on and off states of the tracking mode. It's all explained in the manual. I can override channel 1 and channel 2. I can write the details to the controller. I've got channel 1, channel 2 offset. These allow you to calibrate the various temperature probes, and I can set those values. They are remembered. There are data logging features. So with data logging, we need to specify a directory. So let's just go up here. We'll go into this PC. We'll go into drive D and just make it drive D root. Then we'll go into data logging, and there will be a file here that we'll want to use, which is this one. So we select that. We're going to log the data. Let's automate it so that it will go ahead and get the updates. Refresh rate currently is 10 seconds. We could set it to 30 or 1 minute or 5 minutes. So there, it's just done an update. It's going to update the graph. It's all sorts of other settings that you've got, all sorts of stuff. So just coming back to the AT bias, this is a value which is applied to the ambient temperature. So at the moment it's subtracting -1 to make this 21.5. So the real value is actually 22.5. And so that's a means of calibrating the ambient temperature. This offset here allows you to adjust where the DewController switches on and off for the algorithms associated with ambient, dew point and midpoint. So I was a little bit confused there. You can do manual updates at any time. The time is presented on the graph as well. You can change the values from at the moment it's in centigrade, so we could change it to Fahrenheit, and the values will go to Fahrenheit. The graph will still try and display in Celsius, back to Celsius. So that's basically it. It'll go ahead and log these to a CSV type file. You can plot these at a later date, review them if you want. You can change the labels here. So for example, if I wasn't happy with channel 1 temperature, I could make this, this could be an Orion ED80 for example, and I'll just click on that and it changes it to ED80 temperature. So it makes it a lot more meaningful if you assign what your scopes are to each of these channels, or you can just reset them. The LCD enable allows you, at the moment you can see that the display is actually on. If I turn the LCD off, you notice it's all blanked out. So if you were using this at a star party or something to keep your telescope nice and free from dew, that's something that might come in handy. So I'll just turn it back on. The refresh rate here on the LCD is about every 2 seconds. It uses a timer. So I'm controlling it at the moment via USB. Everything works fine. So that's a project that you can build for relatively little money.